Hi everybody, today we're going to be reviewing the transformations that we've learned. So we have learned how to reflect, how to translate, how to rotate, and how to dilate points and figures. So let's go ahead and practice each and every one of those just to make sure we understand exactly how to apply each transformation. So starting with question 1, we're going to graph the triangle ABC on both of the coordinate planes below. All right, so triangle ABC has the points 1, 4. So this is A. B is at 3, 0. 1, 2, 3, 0 is B. And 3, 1, 2, 3, 4 is C. Okay, now again, I apologize. Doing my very best with these lines here, but they might not be perfect. Okay. All right, so there's our triangle ABC. Now we're going to graph triangle A prime, B prime, C prime, which is going to be a reflection of triangle ABC in the x-axis. So remember, when we reflect over the x-axis, we want to keep our x the same, but our y value negates. So that's the rule. But again, if you don't remember the rule, just think about taking the x-axis and bringing every point the same distance from the x-axis just on the other side. So B is actually not going to move. It's sitting right on the x-axis, so B is going to stay put. Okay, so B and B prime are going to be in the same spot. A, if we apply the rule, A is going to be at 1, negative 4. So 1, negative 1, 2, 3, 4. So this will be A prime, which makes sense because A right now is 1, 2, 3, 4 above the x-axis. So A prime is going to be 1, 2, 3, 4 below the x-axis. C, which is at 3, 4, we're going to make C prime then at 3, negative 4. And again, this is either applying the rule or just counting and making sure we are equidistant from the x-axis below as we are above. So here's our reflected triangle A prime, B prime, C prime, and it's reflected over the x-axis. All right, so graphing ABC once again. So this is in 1, 2, 3, 4. So here's A. B was at 3, 0. And then 3, 4 is C. So once again, graphing that original triangle. We are now going to take this triangle. Oops, sorry. I'm making it worse instead of better here. Okay, so we're going to take this triangle. And this time, we're going to reflect over the y-axis. All right, so reflecting over the y-axis. For this, remember our y value stays the same, but our x value is going to negate this time. All right, so looking at A, if our x value negates, that gives us negative 1, and our y value stays the same at 4. So here's A prime. Our B value, our x value negates, so we're going to go negative 3, 0. And our C value is going to become negative 3, positive 4. All right. Here we go. So here's our reflection over the y-axis. Our points are equidistant from the y-axis on either side. We are in good shape. All right, let's practice more. So now we're going to start with triangle PQR. So let's first graph our original triangle PQR. So P is at negative 1, negative 3. Here's P. Negative 1, negative 1 is Q. And, you know what? I'm going to have to move that, but that's okay. I'll do that in a second. Negative 1, 2, 3, 4, 5. Negative 1. Here is R. Okay, and let me move where I labeled Q here. Okay. Alrighty. PQR. Okay, so what we're going to do first is we're going to rotate this triangle 90 degrees clockwise about the origin. Okay, so clockwise, remember, if you're looking at a clock and your paper is facing straight up, you are going to turn your paper 90 degrees to the right. Okay, so turning our paper 90 degrees to the right, we're going to figure out where that new point is going to be. So I don't know if you guys are doing the same thing as me, but I am turning my paper as we speak here. Okay, so turning my paper 90 degrees to the right, I see that Q is located at -1, 1. So actually, this is going to end up being Q prime here. So -1, 1 is Q prime. R is at -1, 2, 3, or I'm sorry, not R, P is at -1, 2, 3, 1. So this is P prime. And R is located at -1, 1, 2, 3, 4, 5. -1, 5, -1, 1, 2, 3, 4, 5. So this is where R prime is located. All right. Here we go. So that is going to be a rotation 90 degrees clockwise around the origin, creating triangle P prime, Q prime, R prime. Okay, so now we're going to take triangle PQR again. So let me plot that. So -1, -3, -1, -1 is Q, and -1, 2, 3, 4, 5, -1 is R. Okay, so here's our original triangle. Whoop. Okay, so we're going to take this original triangle now, and we're going to dilate it by a scale factor of 2. So dilating, we're going to actually make this triangle larger because we're dilating it by a scale factor of 2, which is a value greater than 1. So when we dilate by a scale factor of 2, we're going to multiply each point, so the x and y value, we're going to multiply each value by 2. Okay, so P prime then is going to be located at -2, -6. So -2, -1, 2, 3, 4, 5, 6. Okay, so here's P prime. Q prime, if we multiply the x and y value by 2, is going to be at -2, -2. So here is Q prime. And then R prime, if we multiply -5 and -1 each by 2, we get -10, -2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. There we go. So here is that original triangle PQR after being dilated by a scale factor of 2. So you can see it doubles in size. All right, next, on to graph number 3. So we are going to now be working with triangle ABC. So we are going to take triangle ABC. First point is located at 1, 2, 3, -5. Oop, I got to adjust my screen here a minute. 1, 2, 3, 1, 2, 3, 4, 5. Here's A. 8, -2, 1, 2, 3, 4, 5, 6, 7, 8, -2. That's B. And C is at 0, 0, right at the origin. Okay. So here's our triangle. All right, again, hopefully your lines are a little straighter than mine here. All right, so the first thing we're going to do with this triangle is we're going to reflect it over the line y equals x. x. So remember that line, if you can't remember what it looks like, think about what your slope is, what your y-intercept is, and how you might graph that line. So here, remember our slope, hang tight. Okay, our slope is 1 over 1. Our y-intercept is 0. So if we think about this, graphing this line starting at 0, 0, we go up 1, right 1, up 1, right 1, up 1, right 1. And we would go down 1, left 1, down 1, left 1 if we wanted to go in the opposite direction. So we're just thinking about first graphing the line y equals x, just so we have an idea of exactly what we're reflecting over. Okay? All right, so we're going to make this blue. Okay. All right, so this is the line we're going to be reflecting over. Okay, so, sorry about that. Alrighty, so thinking about some rules here. So when we are reflecting over the line y equal x, our rule is we switch our x and y coordinates for each point. Okay, so if I want to graph A prime, B prime, C prime, then I'm going to take point A and I'm going to switch the x and y coordinates. So point A is, I should say A prime is going to be located at negative 5, 3. So negative 1, 2, 3, 4, 5, 1, 2, 3. B prime is going to be located at negative 2, 8. So here's A prime, B prime. Now C prime is not going anywhere. C prime is going to stay right here at 0, 0. All right, so here is triangle A prime, B prime, C prime, which is triangle ABC reflected over the line y equals x. And again, I really hope your points or your lines are much straighter than mine. Okay, so let's once again work with this triangle ABC. We're going to graph it first at 3, negative 1, 2, 3, 4, 5. Here's A. 8, 1, 2, 3, 4, 5, 6, 7, 8. Negative 2 is located here. And then C is once again at the origin. Okay, so connecting my points here. Okay, so we have this triangle, and now what we're going to do is we're going to translate it. Let's see, x minus 10. So x minus 10 means we're going to go left 10, but up 5. Okay, so each point we're going to move left 10, up 5. So if I'm going to move A first, looking at A, I'm going to start at A and I'm going to go left 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 5, 1, 2, 3, 4, 5. Okay, so here is where A prime is located following that translation. Next, for C, I'm going to go left 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 5. Okay, and this is going to be C prime. And B prime, same deal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1, 2, 3, 4, 5. Okay, here we go. So each point from our original triangle, we moved left 10, up 5. There we go. And there is our translation for triangle A prime, B prime, C prime. All right, let's keep going. So this last one, folks, with my notes here, we're going to be using some different points. So for question 4, part A, we're going to plot point D, which is at negative 1, 6. E, which is at negative 5, 3. And F, which is at negative 1, 1. Okay, so that's going to be our original triangle or our pre-image. So let's go ahead and graph that. So negative 1, 1, 2, 3, 4, 5, 6. Here's D. Negative 5, 1, 2, 3, 4, 5, up 1, 2, 3. Here's E. And negative 1, 1 is F. So here is our original triangle, or our pre-image, and we're going to reflect this triangle over the line x equals 2. Okay, so once again, it's really important for us to identify where x equals 2 actually is. Think of Hoy and Vux. So Vux tells us we will have, a vertical line with an undefined slope when we have an x equals function. So x equals 2 runs right through where we have an x value of 2. Actually, let's do blue again. I liked blue. Okay. So we're going to reflect over this line x equals 2. So remember what that means. We don't really have a rule for this. We're just trying to make sure that each point, which right now is to the left of that line, ends up on the right side of that line, the same distance away from it and directly across from its original point. So if I'm going to try and plot D prime here, I'm going to start at D and I'm going to say, okay, so D is located 1, 2, 3 to the left of x equals 2. So D prime is going to be 1, 2, 3 to the right of the line x equals 2. And remember, we want D and D prime to be in line with each other. So E is located 1, 2, 3, 4, 5, 6, 7 to the left. So we're going to go 1, 2, 3, 4, 5, 6, 7 to the right for E prime. F is 1, 2, 3 to the left. So 1, 2, 3 to the right gives us F prime. So here is triangle DEF reflected over the line x equals 2 to create D prime, E prime, F prime. Okay. Last but not least, we're going to take a different triangle this time. So we're actually going to use, this time around, we're going to use point G, which is located at 0, 2. Point H, which is located at 3, negative 1. Oops, sorry about that. And point I, which is at negative 1, negative 1. Okay, so let's graph the original triangle here, GHI. So 0, 2 is G. 3, negative 1 is H. And then negative 1 is I. So we're going to graph this original triangle. I'm not sure if this is coming through, but my 2.5-year-old is refusing to nap right now and calling my name. So I apologize if you have to hear that. All right, so we're going to dilate this triangle by a scale factor of 3. So once again, we are making this triangle larger. In fact, we're going to make it 3 times as large as this original triangle here. So I'm going to take every x, y value for the points G, H, I, and I'm going to multiply them by 3. So 0, 2 becomes 0, 1, 2, 3, 4, 5, 6 for G prime. 3, negative 1 becomes 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 3. There's H prime. And then I is going to become negative 3. Negative 3. So here's I prime. All right. So now, oopsies. My apologies. We're just running through stuff right now. Here we go. Okay, so G prime, H prime, I prime is 3 times the size of original triangle GHI. All right, so there's a nice review of all the different transformations that we learned about in this unit. That's going to be the end of this particular part of Geometry 2. We're going to be moving on to Geometry 3 next, where we'll begin volume.